Today's video, we're going to start talking about work in a physics sense and just some basics behind it. Work defined. When a force acts upon an object to cause displacement of that object. That is what work is. So force and displacement have to occur for there to be work. So there are three key ingredients. Force, displacement, and then cause. And that just talks about direction, right? So now the equation for work is right here. Force times distance times the cosine of theta. So that's the angle that the force and the displacement have to each other. So here's an example. You got a force that's acting to the right, and the object displaces to the right. So the force and displacement vector are same in direction. Therefore, our angle is 0. And we put in the equation force times d times cosine of 0, which is in this case 1. Another scenario is this one, where the displacement and the force are going in opposite directions, like you're pushing to get something that's traveling towards you, or friction. Your theta is going to be 180 degrees, and that turns out to be -1. So you end up getting negative work there, and that's something we'll talk about. And then our third scenario, you got the displacement going to the right, but the force going upward. So like you're carrying a suitcase, you're holding a suitcase up while traveling to the right. When you do that, your force is 90 degrees. The cosine of 90 is 0, which means no work is being done. So the idea is that if they're on the same plane, right, then we expect to see work being done. But if they're at 90-degree angles to each other, the force and displacement, we expect no work to be done. Now, to do work, forces must cause displacement. So if you're pushing against a wall, no matter how hard you push, if that wall isn't moving, you are not doing any work. Okay, so no work is being done there. Now let's take a look at an inclined plane, and this is one that's commonly missed. Is that, let's say we have an angle that we're traveling. If the force and displacement are in the same direction, right, both going up the slope, then our angle is still 0 degrees because we're looking at the angle of motion here. Okay. So that angle's 0. We're not worried about the angle of the incline. As we change incline, our force will change, which in turn will change our work. But the force and displacement are both going in the same direction. Therefore, our angle is 0. And then, meaning of negative work, that just means the force and direction are in going opposite ways. So that means we get negative work. Units of work. It's called the joule. So a joule is just a force unit times a distance unit, so newtons times meters. So 1 joule is 1 newton times meter. A couple of examples that you may encounter, at least initially. So we're applying a force of 100 newtons to a 15 kilogram block, and we're moving at a distance of 5 meters at a constant speed, if that means anything to us. But when we're talking about work, all we worry about is force times distance. So we take 100 times 5, right? And then we multiply by the cosine of our angle, which since they're both going this way, our angle is 0. The cosine of 0 is 1. So 100 times 5 times 1 is 500 joules. Here we have an angle. So same force, 100 newtons. It's applied at an angle 30 degrees, moving 5 meters. So we still have the same force. So we're still taking 100, and we're still multiplying it by 5. But now we're multiplying it by the cosine of 30. So when we take 100 times 5 times the cosine of 30, we get work of 435 joules being done. So when we're at an angle, we get less work being done. And then in diagram C, we're applied to an object, right? And we're applying a force. It's applied to lift a 15 kilogram object to a height of 5 meters at a constant speed. And if we just take our force multiplied by 5, we could get that. So if we take F, and we'll say our F's still going to be 100, right? So we'll take 100 times 5, and that's 50. Now, since the force and the direction are both going upward, our angle is 0. So that means the cosine of 0 is 1. So our answer is 500 joules. A couple other examples. We got a 10 Newton force that's pushing a block across a friction-free surface for 5 meters to the right. our force, the only force, these two forces are going up and down. Our object's going this way, so the only force that's doing any work is the applied force. 10 times 5 times the cosine of our angle, which is going to be 0. So 10 times 5 times 1 is 50 joules, and that's going to be to the right. We have a frictional force going backwards in this case, but again, it's displacing to the right. These two are 90 degrees. They don't count. The only force we're worried about is our 10, but since it's going left, it's going to be negative 10 times 5, and actually it's going to be positive 10 times 5 times the cosine of 180, and that's where our negative comes in. That gives us negative 1. So 10 times 5 times negative 1 is negative 50 joules. Now we have some opposing forces. Okay, the object is moving to the right, so therefore normal force and gravity don't apply to work because they're at 90s. But now we got two different forces. So we got the force applied, so we got the work for the applied force, which is 10 times 5 times the cosine of 0, which is positive 50 joules. And then the work due to friction, which is 10 times 5 times the cosine of 180, which is negative 1, which means we get negative 50 joules. So net force, or net work, will be 0, but we're doing positive 50 to the right and negative 50 to the left. This one, we get an object that's sliding at a constant speed to the right. But if we look, both our forces are going up and down. So therefore, there's no force making it go to the right, but it's still going to the right, which means our work is force times displacement times nothing because there's no angle, which means our work is 0. And then lastly, we get an object that's being pulled upward at a constant speed with a 20 Newton tension force and 20 newtons of gravity, displacement of 5 meters upward. So we got these two going this way. So we got work because of tension. The work because of our tension is 20 newtons of force times 5 meters of displacement. And since they're going in the same direction, our angle's 0, cosine of 0, that's 100 joules. But our work due to gravity, it's still 20 newtons of force, and it's still traveling 5 meters, but our angle, since the direction in this gives us 180 degrees, it's the cosine of 180, which is negative 1 times 20 times 5, negative 100 joules. So that's work. There are more example problems out there that you'll be able to watch later, but this is just a general overview of work.